Welcome. This is practice paper for or predicted paper. Practice paper, or you can call it as predicted paper for AAHL paper 1 for the upcoming examinations. Question number 1. The nth term of an arithmetic sequence is given by the formula un equals to 15 minus 3n. Find the first term. First term means n equals to 1. So u1 equals to 15 minus 3 times 1, which is going to be 15 minus 3, which is 12. That's part A. Part B, given that nth term of the sequence is negative 33, find the value of n. So 15 minus 3n equals to negative 33. Negative 3n equals to negative 33, negative 15. Negative 3n equals to negative 48, n equals to 16. Part C, find the common difference. So, common difference is going to be nothing but what? u2 minus u1. u2 means 15 minus 3 times 2 minus u1. u1 just now we got it as 12. So, which is nothing but what? 15 minus 6 minus 12, which is negative 3. So, the common difference is negative 3. That's going to be the answer. Now, coming to the next second question. Second question is from functions. We have vertical asymptote, horizontal asymptote, and being asked vertical asymptote, horizontal asymptote, and so on. So let's try to solve it out. So what is being the question is being asked over there? The function f of x equals to 1 minus 1 upon x minus 2. 1 minus 1 upon x minus 2. Find the vertical asymptote. Whenever the vertical asymptote means denominator equals to 0. So for vertical asymptote, remember denominator equals to 0 implies x minus 2 equals to 0. So x equals to 2. Then second one, horizontal asymptote. Horizontal asymptote is going to be f of x equals to 1. Y equals to 1 is going to be the horizontal asymptote. So over here, concept we do it out. If y equals to a plus b by cx plus d. So for vertical asymptote, c plus cx plus d should be equals to 0. And for horizontal asymptote, y equals to a is going to be the concept. Find the coordinates of the point where the graph y f of x meets x-axis and y-axis. So what is that? That is for part B. Y equals to 1 minus 1 upon x minus 2. X-axis. X-axis means y equals to 0. So what does it becomes? 0 equals to 1 minus 1 upon x minus 2. 1 upon x minus 2 equals to 1. So x minus 2 equals to 1. X equals to 3. So 3 comma 0. Then for y-axis. Y-axis means x equals to 0. So y equals to 1 minus 1 by 0 minus 2. 1 minus 1 by 1 minus 2. So 1 plus 1 upon 2, which is 3 upon 2. 0 comma 3 upon 2. That's going to be the answer. Now coming to question number 3. The quadrilateral OABC is shown in the following diagram. Now what is being asked over there? OABC is symmetrical along OB. It is symmetrical along OB. A has a coordinate 6, 0. So this coordinate is 6, 0. C has a coordinates 3, 3 root 3. Write down the coordinates of the midpoints of AC. Midpoint formula we know x1 plus x2 by 2, y1 plus y2 by 2. So which is going to be nothing but how much? 6 plus 3 by 2, 0 plus 3 root 3 by 2. So which is going to be nothing but how much? 9 upon 2, 3 root 3 by 2. That's going to be the midpoint of AC. A part 1. A part 2. Hence or otherwise, find an equation of a line passing through O and B. we have to find it an equation of a line which is passing through O and B. O is 0, 0 and B we don't know. So we have drawn it out AC, midpoint of AC. This is going to be the midpoint of AC and it's going to be 9 by 2, comma 3 root 3 by 2. So I want to this point maybe D. OD is D is on OB. We can say that D is on OB. So therefore gradient of OD equals to y2 minus y1 by x2 minus x1, which is going to be 2 gets cancelled, 3 root 3 by 9, which is root 3 by 3. Gradient of OD is this one. Then the equation will be y minus y1. Equation of what line is he asking it out? Find the equation of a line passing through O and B. Y minus y1 equals to m. M is root 3 by 3 times x minus x1, because the point I have taken as 0, 0. So what is going to be the answer? Y equals to root 3 upon 3 x. That's going to be the answer. Now coming to question number 4. In question number 4, consider the function f of x equals to cos x and g of x equals to sin 2x. We have to do that. F of x equals to cos x and g of x equals to sin 2x. The graph f intersects the graph g at point A and B, 0 pi by 2 comma 0. So this point is going to be pi upon 2 comma 0. That is going to be the point. Now what is being asked over there? Find the x coordinate of A and the x coordinate of C. We have to find it out the x coordinate of A and also x coordinate of C. So first of all, these two curves are intersecting. Cos 2x equals to part A, cos x equals to sin 2x. Cos x equals to sin 2x. So cos x equals to sin 2x formula is nothing but what? 2 sin x cos x. Then 2 sin x cos x minus cos x equals to 0. Then cos x common, 2 sin x minus 1 equals to 0. So either cos x equals to 0 or 2 sin x minus 1 equals to 0. Cos x cannot be equals to 0 because cos x equals to 0 means x equals to pi by 2. Cos x equals to 0, so x equals to pi by 2, which becomes nothing but what? Point B itself only. So sin x equals to 1 by 2. So x equals to sin inverse 1 by 2 is nothing but what? Pi by 6. Cos 30, pi by 6. That is one another answer. Another answer will be pi minus pi by 6, which is going to be 5 pi by 6. So coordinate A will be having pi by 6 and coordinate C will be having 5 pi by 6. That's going to be the answer. The shaded region R is enclosed by the graph F and G between B and C. Find the area of R. So we have to find it out the area of R. Let me quickly add a page for that. Then over, so area is going to be equals to, I am going to find it out the area means nothing but what? I need to find the integration of the curves. Integral of the curves is going to give you the area itself only. So for that we need to check which is the upper curve and which is the lower curve. So I'm going to look at the graph and identify which one is the upper curve and which one is the lower curve. So let's go back to the graph once again and check which is going to be the upper curve and which is going to be the lower curve. So area area equals to integral. This is the upper curve and this is the lower curve starting from pi by 2 to 5 pi by 6. This point was 5 pi by 6. So upper curve is f of x and the lower curve is nothing but what? G of x. Lower curve is g of x. So it will be area from pi by 2 to 5 pi by 6 cos x minus sine 2x dx. Now, what is cos x integral? Cos x integral is going to be nothing but what? Sin x minus cos 2x into sin 2x integral is negative cos 2x divided by 2 from pi by 2 to 5 pi by 6, which is going to be sin x plus 1 upon 2 cos 2x from pi by 2 to 5 pi by 6. Now, what am I going to do that? I am going to substitute the values. Sin 5 pi by 6 plus 1 upon 2 cos 5 pi by 3. This is upper limit minus sin pi by 2 plus 1 upon 2 cos pi. Then this is 1 upon 2 plus 1 upon 4 minus 1 minus 1 upon 2. So which is going to be 1 upon 4. So answer is going to be nothing but how much? 1 upon 4 is going to be the area of the shaded region. That completes question number 4. Now come to question number 5. The binomial expansion. This is all about question number 5. In this one, the binomial expansion 1 plus kx whole to the power of n. 1 plus kx whole to the power of n is been there. And we have to find the value of n and k. What are the values that we are supposed to find it out? The values of n and k. So for that, what am I going to do? Expand it out. 1 plus kx whole to the power of n will become 1 plus nc1 kx plus nc2 k square x square and so on, and k plus k power n x power n. Now, but this has been given as 1 plus 12x plus 28 k square x square. So from that, equate it out. nc1 k equals to 12. So nk equals to 12 and nc2 k square equals to 28k square. So nc2 means n times n minus 1 by 2 equals to 28. So n square minus n equals to 56. N square minus n minus 56 equals to 0, which becomes n minus 8 times n plus 7 equals to 0. So n equals to 8 or n equals to negative 7. N cannot be negative 7. N cannot be a negative number, so n equals to 8. Plug in n equals to 8 over here. So we'll be getting it out 8k equals to 12. From there, k equals to 12 by 8, which is equals to 3 upon 2. That was question number 5. Now come to question number 6. What is that question number 6? Prove by mathematical induction 5 power 2n minus 2 power 3n is always divisible by 17. So how many marks question? 7 marks question. So let Sn is 5 power 2n minus 2 power 3n is divisible by 17. So n equals to 1. So 5 power 2 minus 2 power 3. 25 minus 8, 17. So yes, therefore Sn is true for n equals to 1. Let us assume Sn is true for n equals to k. So Sk equals to 5 power 2k minus 2 power 3k equals to 17 times of something, 17 times of p. So 5 power 2k equals to 17p plus 2 power 3k. We have to prove Sn is true for n equals to k plus 1. So 5 to the power of 2 times of k plus 1 minus 2 to the power of 3 times of k plus 1. When I simplify that, I should be able to get 17 times of something. So this will become 5 to the power of 2k plus 2 minus 2 to the power of 3k plus 3. So 5 power 2k times 5 square minus 2 power 3k times 2 cube. 25 times 5 power 2k minus 8 times 2 power 3k. So we will be taking it as 5 power 2k. What is 5 power 2k? Is 17p plus 17p 17p plus 2 power 3k minus 2 power 3k times 8. So which is going to be nothing but how much? 25 times 17p plus 25 times 2 power 3k minus 8 times 2 power 3k. So when I take 17p common, so what do I get it out? 17 common, it becomes 25p plus 2 power 3k. So therefore, Sn is true for n equals to k plus 1. So once we write it out, don't forget to write it out the general solution. So since Sn is true for n equals to 1, n equals to k, and n equals to k plus 1 by PMI, Principle of Mathematical Induction, it is true for all n belongs to positive integers. That's going to be the answer. Now coming to question number 7. Now question number 7 is a kind of trigonometry question, and also be careful for that. Question number 7. So what should I be doing it out in this question number 7? Consider the function f of x equals to secant x. F of x equals to secant x minus pi by 4. Determine the range of f between 0 to pi by 2. So I'm going to find it out f of 0. F of 0 is going to be secant 0 minus pi by 4, which is going to be root 2. Then I'm going to find it out f of pi by 2, which is secant pi by 2 minus pi by 4, which is going to be again root 2, which is pi by 4 minus pi by 4 is going to be pi by 4, which is again nothing but what? Root 2. Then I will try f of pi by 4 in between. So it will become secant of pi by 4 minus pi by 4, which becomes 0, secant 0, which is going to be 1. So always it lies between 1 and root 2. So that is going to be the range. The range bounded by the graph and x-axis and this much is rotated by 2 pi radians along x-axis. Find the volume generated. So volume equals to pi integral, this is x-axis, y square dx from 0 to pi by 2. So it's going to be pi integral 0 to pi by 2 secant square x minus pi by 4 dx. So integral of secant square is nothing but what? Tan x minus pi by 4 from 0 to pi by 2. Plug in that value now. Pi tan pi by 2 minus pi by 4 minus tan 0 minus pi by 4. So which becomes tan pi by 4 minus tan minus pi by 4. So tan pi by 4 is 1 minus of minus 1. So it's going to be nothing but what? 2 pi. So the answer is 2 pi. Now coming to question number 8. So in this question number 8, what is the thing? A continuous random variable. So this is from probability and statistics part. So what is it being told? A continuous probability distribution function. So let's try to start to solve it out. If x lies between a to c, this is a function. Between c to b, this is going to be the function. Then consider the following graph shows y equal to f of x. Given that c is greater than or equal to a plus b by 2. Find an expression for the median. So we are supposed to find it out the median. So where does the median lies? Obviously the median lies in the first one. So the median is going to be the first one, first function. So from a to, it is starting from a to median, 2 by b minus a times c minus a x minus a dx. That's going to be the median. That area should be equals to 1 upon 2 because median means 50%. 50% means area is 1 upon 2. Now I am going to find it out the area of that one. So 2 upon b minus a times c minus a x minus a whole square by 2 from a to m equals to 1 upon 2. Now plug in the upper 2 and 2 gets cancels. Plug in the upper limit m minus a whole square upon b minus a times c minus a minus a minus a whole square upon b minus a times c minus a equals to 1 upon 2. Then from there, what do I get it out? M minus a whole square upon b minus a times c minus a equals to 1 upon 2. So from there I get m minus a whole square equals to b minus a times c minus a upon 2. So m equals to a plus minus square root of plus or minus square root of b minus a times c minus a upon 2. Now, because we know that m is greater than a, so we take only the value m equals to a plus square root of b minus a times c minus a by 2. That's question number 8. Now coming to question number 9. So in that question number 9, so there are 12 questions in this paper. So we are doing it at the question number 9 for that one. Till now we have covered 8 questions. Now in this we are going to cover question number 9. Now we can see that this question number 9 is from which concept? A teacher takes n students for a field trip. So we are taking the students for a field trip over there. How many students are there? There are n students are there in the field trip. Now, after that, when there are n students in the field trip, the students are assigned randomly into 2 groups. So, how many groups are then being arranged? They are being arranged into 2 groups. Now, what is that is being told? So, I have n students and 2 groups. For safety reasons, there must be exactly 3 students. There must be exactly how many students? 3 students in the first group and at least 3 students in the second group. The teacher will randomly assign these 3 students to the first group and other to the second group. Find the expression for the number of ways a student can be assigned. So it is just NC3, randomly 3 students, so NC3. Remaining will go to the remaining other second group. 2 of the students are asked the teacher not to work in the same group. 2 of the students, so let those 2 students be A and B. They should not go into the same group. The teacher agrees and now finds the number of ways to assign the students is halved. Determine the value of n. So now what is the thing is, I have these 2 students. How many students I have? 2 students. They have to go into one of the group, 2C1. Then out of n students, 2 students have gone. So remaining will be nothing but what? N minus 2. 2 already kept aside. They are already kept aside. So remaining, how many will be remaining? Remaining will be n minus 2. From this n minus 2, what is the thing is, I have to select two more, n minus 2 C2. Why? Because already one is selected and two more will be selected. So they will be adding up to 3 students. So this is in the first group. So this is first group or any one of the group. And he says that now it is halved. So 1 upon 2 NC3 divided by 2 will be equals to 2C1 times n minus 2 C2, because it has been halved. He says that it has been halved. So what is the thing? Starting once again, there were how many students in the beginning? N students were there. A and B were the problematic. So I chose 2C1. So 2C1. So remaining out of n, n minus 2 will be left over. And two more students have to be selected. So n minus 2 C2. So totally there will be 3 students. Now I have to find it out the value of n from here. So NC3, 1 upon 2, NC3 means n times n minus 1 times n minus 2 by 3 factorial equals to 2C1 is 2. Then n minus 2 C2 will be n minus 2 times n minus 3 by 2 factorial. So from here, what can happen? N minus 2 gets cancels. Then 2 and 2 gets cancels. Then I am left over with n times n minus 1 equals to 12 times n minus 3. Now it is your choice. You can do it as a quadratic or you can solve it out over here. So if at all I'm doing it out as a quadratic, n square minus n minus 12n plus 36 equals to 0. So I'll get n square minus 13n plus 36 equals to 0. So which becomes n minus 9 times n minus 4 equals to 0. So I get n equals to 9 or n equals to 4. N equals to 4 is not possible at all. Therefore, n equals to 9 is going to be the answer. That completes section A. Now coming to section B. Section B is much more longer process and not as easy as the first section. Section A will be very easiest one, but section B will be the somewhat difficult, but not as easy, but it is somewhat difficult over there. So let's do section B. And each question is of more than 10 marks. In this one, in this case, section B, the first question is for 14 marks. So what is being asked in this question number 10? A circle x square plus y square equals to 9 has a center 0, 0 and radius 3. A triangle PQR is inscribed in the circle with the vertices P, Q and R are variable points in the first and fourth quadrants. This is shown in the diagram. For point Q, show that y equals to 9 minus x square. So we know that x square plus y square equals to 9. So y square equals to 9 minus x square, y equals to plus minus square root of 9 minus x square. But since y is positive, so therefore I take y equals to only plus square root of 9 minus x square. So that condition has to be written over there. Now coming to part B. Hence find the expression of A, the area of the triangle. We are going to find it out the area of the triangle. So what am I going to do that? So y was square root of 9 minus x square. Now area of a triangle. Area equals to half times base times height. Half times base times height. Half base. Base is going to be 2y. So which is going to be 2 times of square root of 9 minus x square. And height. What's going to be the height? This part is x and this part is 3. So height is going to be x plus 3. So height is x plus 3. So what's going to be that answer? Square root of 9 minus x square times x plus 3 is going to be the area. Show that dA by dx equals to this one. So let me add a page over there. So I got it out. A equals to square root of 9 minus x square times x plus 3. So dA upon dx equals to square root of 9 minus x square times x plus 3 derivative is 1. Again x plus 3 as it is 1 by 2 root of 9 minus x square minus 2x. Remember what I have done it out? I have done root x derivative is 1 by 2 root x. That is a formula I have used. So square root of 9 minus x square derivative is 1 by 2 root of 9 minus x square times minus 2x. So it's going to be square root of 9 minus x square minus, then 2 and 2 gets cancels, x square plus 3x divided by square root of 9 minus x square. Easy asking us to prove, then still take 9 minus x square as a common denominator. Square root of 9 minus x square as common denominator, 9 minus x square minus 3x, which is 9 minus 3x minus 2x square divided by square root of 9 minus x square. Then, hence or otherwise, find the y coordinate of R such that A is maximum. We have to find it out. Y coordinate of R such that A is maximum. A is maximum means nothing but what? dA by dx should be equals to 0. So 9 minus 3x minus 2x square by square root of 9 minus x square equals to 0. So what does it becomes? 9 minus 3x minus 2x square equals to 0. So 2x square plus 3x minus 9 equals to 0. Factorize it out. 2x minus 3 times x plus 3 equals to 0. So 2x minus 3 equals to 0. X plus 3 equals to 0. So x equals to 3 upon 2. X equals to negative 3. So x equals to negative 3. X equals to negative 3 is not possible because x is in the positive quadrant for the values of x. So x equals to negative 3 is not possible. So x equals to 3 by 2. So y equals to square root of 9 minus x square, which is going to be square root of 9 minus 3 upon 2 whole square, which is square root of 9 minus 9 by 4, which is going to be square root of 27 upon 2. Now y coordinate of R such that A is maximum. So therefore, where is R? R is in the down fourth quadrant. So R is negative. So therefore, don't forget to write it out minus over here. Otherwise, you tend to lose 1 mark. That's going to be the answer for question number 10. Now we are left over with question number 11 and 12. Question number 11. So let's see what is this question number 11 is about. It is about the polynomial function p of x. It's about a polynomial function p of x equals to 3x cube plus 5x square, 3x cube plus 5x square, and plus x minus 1. So it is 3x cube plus 5x square plus x minus 1. Then what has been asked over there? Show that x plus 1 is a factor of p of x. So for x plus 1 to be a factor of p of x, what am I going to do? Use the remainder theorem. So when I use the remainder theorem, I am going to get the value of what is this? I am going to, if the remainder is going to be 0, then it's going to be a factor of x. So I am going to use the remainder theorem for that. So when it is divided by x plus 1 means x p of minus 1, it should be equals to 0. So I will be doing it out over there. Let me starting a new page or over here. So p of minus 1, which is going to be 3 times of minus 1 whole cube plus 5 times of minus 1 whole square plus of minus 1, which is negative 3 plus 5, negative 1, which is going to be 0. Therefore, x plus 1 is a factor. Now, next part B. Hence, express P of x as a product of linear factors. So what am I going to do? I am going to do the synthetic division for that. What is the synthetic division? 3, 5, 1, negative 1, negative 1, 0. 3 plus 0 is 3. 3 times negative 1 is negative 3, 2. Then 2 times negative 1 is going to be negative 2. Then it's going to be negative 1. Then 1 times negative 1 times negative 1 is nothing but what? 1. So the remainder is going to be 0. So this is what x cube, x square, x. So this will become x square, x and a constant. So it will become x plus 1 times 3x square plus 2x minus 1. Now x plus 1 times, this factorize it out, this one will again becomes x plus 1 times 3x minus 1. So I have written as a factor of linear factors. Next, what has been asked? Now consider q of x equals to this much, express q of x in a partial fractions. So what is q of x? X plus 1 upon 2x plus 1. Part C. So 1 upon q of x is equals to 1 upon x plus 1 times 2x plus 1. So which is going to be a upon x plus 1 plus b upon 2x plus 1. So from there 1 equals to a times 2x plus 1 plus b times x plus 1. So x equals to negative 1. So 1 equals to a times negative 2 plus 1 plus b times 0. So 1 equals to negative a equals to negative 1. X equals to negative 1 upon 2. So 1 equals to a times 0 plus b times negative 1 upon 2 plus 1. 1 equals to 1 upon 2b, b equals to 2. So what's going to be the fraction now? 1 upon x plus 1 times 2x plus 1 equals to negative 1 upon x plus 1 plus 2 upon 2x plus 1. Hence or otherwise show that this entire thing equals to that. Hence or otherwise. It is hence or otherwise. So this is part D. 1 upon x plus 1 times x plus 1 times 2x plus 1 equals to. We can clearly see that this part and this part are the same. So it's going to be 1 upon x plus 1 times this entire fraction, which is minus 1 upon x plus 1 plus 2 upon 2x plus 1. So it is going to be minus 1 upon x plus 1 whole square plus 2 upon x plus 1 times 2x plus 1. Now again minus 1 upon x plus 1 whole square plus 2 times of this one is again minus 1 upon x plus 1 plus 2 upon 2x plus 1. So which is going to be nothing but what? Minus 1 upon x plus 1 whole square minus 2 upon x plus 1 plus 4 upon 2x plus 1. I think so that is only been asked us to find it out. Hence find the integral of this. We are supposed to find the integral of that. So integral of part E, integral of 1 upon x plus 1 whole square to x plus 1. 1 upon x plus 1 whole square times 2x plus 1 dx is going to be integral of 4 upon 2x plus 1 minus 2 upon x plus 1 minus 1 upon x plus 1 whole square. So this becomes 2 ln of 2x plus 1 minus 2 ln of x plus 1 then plus 1 upon x plus 1 plus c. That's going to be the answer. And final part of that one is what? Consider the function f of x equal to p of x by x plus 1 times q of x. X is not equal to minus 1, this one. Limit x tends to minus 1, x tends to minus 1 f of x, x tends to infinity f of x. Part F, limit x tends to negative 1, f of x is going to be limit x approaches negative 1, x plus 1 whole square times 3x minus 1 divided by x plus 1 whole square times 2x plus 1, which is going to be limit x approaches negative 1, 3x minus 1 by 2x plus 1. So plug in 3 times negative 1 by 2 times negative 1 plus 1, which is going to be 4. Now for part 2. Limit x approaches infinity f of x is going to be limit x approaches infinity x plus 1 whole square times 3x minus 1 by x plus 1 whole square times 2x plus 1. So which is going to be limit x approaches infinity 3x minus 1 by 2x plus 1, which is going to be limit x approaches infinity 3 minus 1 upon x divided by 2 plus 1 upon x. So we know that as x approaches infinity, 1 upon x approaches 0. So this will become 0, 0. So answer is going to be 3 upon 2. Now finally, question number 12. Question number 12 is from complex numbers. So last question will be obviously a somewhat difficult question or a tricky question. So therefore, we need to solve it out very carefully. This is from complex numbers. Let's try to solve it over there. So what does that the question says about? The question says find the binomial expansion of cos theta plus I sin theta whole to the power of 5. Cos theta plus I sin theta whole to the power of 5. So it becomes cos power 5 theta plus 5c1 I cos to the power of 4 theta. I write cos to the power of 4 theta times I sin theta plus 5c2 cos cube theta I square sin square theta plus 5c3 cos square theta I cube sin cube theta plus 5c4 cos theta I power 4 sin power 4 theta, and finally 5c5 I power 5 sin power 5 theta. So what does that becomes now? Cos power 5 theta. And how do I write it out? In terms of cos theta and I sin theta. Cos power 5 theta plus 5 cos power 4 theta sin theta times I, then minus 10 cos cube theta sin square theta minus 5 cos square theta sin cube theta I, then plus 5 cos theta sin to the power of 4 theta, then plus I sin to the power of 5 theta. So combining all the like terms over there, so what does it becomes? Real parts and imaginary parts, cos power 5 theta minus 10 cos cube theta sin square theta plus 5 cos theta sin to the power of 4 theta plus I common 5 cos to the power of 4 theta sin theta minus 10 cos square theta sin cube theta plus sin to the power of 5 theta. Using De Moivre's theorem, show that sin phi theta equals to this one. So cos theta plus I sin theta whole to the power of 5 can be written as cos 5 theta plus I sin 5 theta. So sin phi theta is the imaginary part and this is going to be the imaginary part. So both are equal. So sin phi theta equals to 5 cos to the power of 4 theta sin theta minus 10 cos square theta sin square theta plus sine to the power of 5 theta. So now 5 sine theta, this is cos square theta whole square minus 10 sine square theta times cos square theta plus sine to the power of 5 theta. The reason what I have done it out is cos square theta can be written as 1 minus sine square theta. So that can be written over here. Cos square theta is 1 minus sine square theta and cos square theta is 1 minus sine square theta. So what does that becomes now? 5 times sine theta 1 minus sine square theta whole square 10 sine square theta 1 minus sine square theta plus sine to the power of 5 theta. So it becomes 5 sine theta times 1 minus 2 sine square theta plus sine to the power of 4 theta minus 10 sine square theta plus 10 sine to the power of 4 theta plus sine to the power of 5 theta. So which is going to be 5 sine theta minus 10 sine cube theta plus 5 sine to the power of 5 theta minus 10 sine square theta plus 10 sine to the power of 4 theta plus sine to the power of 5 theta. So it becomes, I have to add them all. This is 10 sine to the power of, this is 10, this one was 10 sine cube theta. This one was 10 sine cube theta. So what do I get from there? So let me make a correction over here. So this becomes 10 sine cube theta, 10 sine to the power of 5, 10 sine cube theta, 10 sine to the power of 5. So when I see that one, 5 sine to the power of 5, 10 sine to the power of 5, sine to the power of 5 becomes nothing but what? 16 sine to the power of 5 theta. Then minus 10 will becomes minus 20 sine cube theta plus 5 sine theta. Then hence show that theta equals to pi by 5 or 3 pi by 5, and the solutions are the solutions for this one. So I am going to factorize it out. Sine phi theta equals to sine theta times 16 sine to the power of 4 theta minus 20 sine square theta plus 5. Now we know that sine phi times pi by 5 is equals to 0. Why? It is equals to sine pi. Sine pi is going to be 0. And sine of phi times 3 pi by 5 equals to sine 3 pi. Sine 3 pi is also going to be 0. So pi by 5 is a solution for this one, and 3 pi by 5 is also solution for this one. So automatically understood, pi by 5 is also solution for this, and 3 pi by 5 is also solution for this. So pi by 5 comma 3 pi by 5 are solutions for 16 sine to the power of 4 theta minus 20 sine square theta plus 5 equals to 0. Finally, hence show that sine pi by 5 sine 3 pi by 5 equals to root 5 by 4. So we got 16 sine to the power of 4 theta minus 20 sine square theta plus 5 equals to 0. So A equals to 16, B equals to negative 20, C equals to 5. So quadratic sine square theta equals to minus B plus minus square root of B square minus 4AC upon 2A, 2 times 16. So 20 plus minus square root of 400 minus 320 divided by 32, which is 20 plus minus square root of 80 divided by 32, which is 20 plus minus 4 root 5 divided by 32. So which is 5 plus minus square root of 5 by 8. So this is sine square theta. So what will be sine theta? Will be plus minus square root of 5 plus minus square root of 5 by 8. But I take only positive one. I don't take negative one because it is in the first quadrant. Because the solutions are in the first quadrant, so therefore I'm going to take it out always the positive answers only. So what am I going to take? Sine theta equals to either square root of 5 plus root 5 by 8 or sine theta 1 and sine theta 2 equals to square root of 5 minus square root of 5 by 8. So theta 1 was pi by 5, theta 2 was 3 pi by 5 equals to square root of 5 plus root 5 by 8 times square root of 5 minus root 5 by 8. So that's going to be square root of a square minus b square by 64, which is going to be 25 minus 20 by 64, which is going to be square root of 5 by, what is this, square root of 25 minus 5 by 64. So which is going to be square root of 20 by 64, which is going to be square root of 5 by 16, which is square root of 5 by 4. I think so. That is only ask us to prove it as square root of 5 by 4. So that completes this paper. All the best for your exam. See you in the next paper. Bye.